A lamp with a mass of m equal to 42.6 kilogram is hanging from wires as shown in this figure. Here is the figure. I hope you can see all the parts of that figure. You have a lamp of mass 42.6 kilogram hanging from, there are 3 cables in there. Alright, find the tensions in the 3 wires. Now, what is the method that we discussed? Isolate the object or point on which the forces are acting. Now, this problem needs to be done in 2 stages. In the first stage, we identify the lamp as the object and identify the forces acting on the lamp. In the second stage, we identify the point O as the point at which several forces are acting. Alright, let's start by first identifying the lamp as the object on which the forces are acting. Tell me, what are the forces acting on the lamp? One force acting on the lamp is its weight acting vertically down, and the lamp is held in position by this cable, and the tension on that cable is T1. Those are the 2 forces on the lamp. Alright, so I have now the lamp here. I'm going to mark the forces on the lamp. The first force on the lamp is its weight mg, and the other force is the tension T1 that is on this piece of string. Okay, the weight mg and the tension T1 are the 2 forces acting on the lamp. Since there is no net force on the lamp, is there a net force on the lamp? How do you know? Well, you know, if there is a net force, there will be an acceleration. If there is a net force downward, well, heaven help us, the whole thing will fall down. If there is a net force upward, well, of course we will go to heaven then. Well, since none of this is happening, there is no net force on the lamp. That means you can now write an equation. Is that right? Now, remember, when you write equations, they are vectors, so you need to use the proper sign. T1 is a positive vector. Mg is a negative vector, so that will be T1 minus Mg equal to 0. And that gives you T1 right away. T1 equal to Mg. We know M, we know the value of G. That will be 42.6 kilogram times 9.8 meter per second squared, and that is 417.5 Newton. So that simple operation of identifying this lamp as the object on which the net force is 0, we were able to obtain one value. We now know T1. So wherever we want to use T1, we can now use 417.5 Newton. Alright, now you notice that I have changed my diagram. I have now identified O as the point. And did you see that earlier that tension T1 was acting up? That means that was supporting the lamp. When the cable is supporting the lamp, the tension on it is upward. But now when you consider the point O, the direction of the tension is downward. That tension is pulling the point O downward. Did you understand how arbitrarily I can change that direction? Yes, indeed. Now, if you notice in here, let's watch this one. When this mass is hanging, the tension on this cable is upward. because it is balancing the weight of the mass. But if you now look at the forces at this point, that tension is now downward because that force is pulling this point downward. So when you now consider the forces at the point O, the tension T1 is actually downward. Alright, we will now consider the forces acting at the point O, and in that case the direction of T1 is downward. There you are. Alright, let's draw those in here. This is the point O, and the tension T1 equal to 417.5 Newton is acting downward. Alright, the tension T1, can you write that in the component form? Well, it is a proper Y force. Can you write that in the component form? This is made up of 0x and negative 417.5 in the Y direction. Therefore, look at the way I write that. T1 equal to negative 417.5 Newton J. That is the proper way to write this force. This is a negative Y force. That is what we have said here. T1 is a negative Y force, and write that in the component form. T2 makes an angle of 120 degrees with the x-axis. How do I know that? Well, this is T2. Let me see if I can show that to you. Well, this is the x-axis. We are told that this angle is 60 degrees. Well, that disappeared, the one I drew. There you are. Now, this is 60 degrees, this is the x-axis. That means this angle is 60 degrees. Is that right? Yes. And the angle made by T2 with the x-axis is this angle. That will be 180 minus 60, that is 120 degrees. So the angle made by the vector T2 with the x-axis is 120 degrees. It's very important to recognize the direction of each vector. Tell me, what is the angle made by T3 with the x-axis? Because this angle is given to be 30 degrees, this angle also will be 30 degrees. Okay. Now this is T2 that makes an angle of 120 degrees. Can you write T2 in the component form? Therefore T2 will be T2 cos 120 degrees I plus T2 sine 120 degrees J. The x component of T2 plus the y component of T2. And that will be using the values of cos 120 and sine 120. You know cos 120 is negative. So that will be negative 0.5 T2I plus 0.87 T2J. That is T2. Now, the x component is negative 5. This is the x component. Look at that. It is negative. And this is the y component. So this is T2 cos 120 degrees is the x component. And T2 sine 60 degrees is the y component, which has this value. Negative 0.5 T2, that is this vector, plus 0.87 T2, that is this vector. Alright, we finished with T2. Can you do the same thing with T1? Alright, T1 make, not T1, T3, T1 we already dealt with. T3 makes an angle 30 degrees with the x-axis. It means its component form is T3 equal to T3 cos 30 degrees I plus T3 sine 30 degrees J. And can you obtain these values like this? This is T3 cos 30 degrees and this is T3 sine 30 degrees, and that will be 0.87 T3I plus 0.5 T3J. Well, we have now three forces acting at the point O. The first force is T1, which is negative 417.5 Newton J. The second force is T2, which is equal to negative 0.5 T2I plus 0.87 T2J. We don't know what T2 is, we need to find T2. And the third force is T3 equal to 0.87 T3I plus 0.5 T3J. What is the situation? Since the net force at that point O is 0, if you add T1 plus T2 plus T3, that net force must be equal to 0. Since the net force at O equal to 0, we say T1 plus T2 plus T3 equal to 0. What does that mean? It means if you add the x components, it must be equal to 0. And if you add the y component, it also must be equal to 0. That is the meaning. When vectors are written in the component form, and if we say adding the vectors will give you 0, it means adding the x components will produce 0, adding the y components also will produce 0. So what do? The sum of the x components must be 0 and the sum of the y components must be 0. That means if you add the x components, look at this, negative 0.5 T2 added to 0.87 T3 must be equal to 0, and 0.87 T2 added to 0.5 T3 added to negative 417.1. They are all y component. There are 3 y components and 2 x components. Look at this. There are 3 y components. This is 1 y component. There are 2 over here. Adding those 3 forces must give you 0. So let's make those equations. These are the equations we had earlier. So adding the x components give you negative 0.5 T2 plus 0.87 T3 equal to 0. Adding the y components give negative 417.5 plus 0.87 T2 plus 0.5 T3 equal to 0. And you have 2 equations. Now let's rewrite these equations. Negative 0.5 T2 plus 0.87 T3 equal to 0. And 0.87 T2 plus 0.5 T3 equal to 417.5. Well, can you solve these equations on a calculator? Well, let me see if I can show that to you. I'm going to keep the calculator in front of the camera and see how best you can see that. Now, these are